with you and Mr. Mun. So I have visited your factory in Taoyuan when I visit Dr. Leo.
Yeah, I think he will show up later.
Yeah.
Okay.
So I would like to introduce Mr. Mun. So he's the president of the Asian Vietnam Hydrogen Club.
Yeah, very nice to meet you. Yeah, thank you. And welcome, my friend from Bangkok. It's Yamasaki. He's from Kawasaki Heavy Industry.
Good morning, everyone. My name is Yamasaki. I'm working for Kawasaki Heavy Industries. Thank you for the invitation today. Yes, I have a great interest in the Vietnam, the hydrogen business in Vietnam. Thank you.
Good morning, everyone. Good afternoon, everyone. And I think that we will begin shortly, about a minute, and then we will go. Okay. So, good afternoon and good morning, everyone, and a very welcome to the Vietnam Taiwan Hydrogen Cooperation Webinar, connecting technology, realizing the green hydrogen strategy. My name is Sam, and will be your master of ceremonies for today's session. Before we begin, a few quick notes. This session is conducted in English. Please keep your microphone muted unless you're called to speak, or if you have any question along the way, please type in the podcast or the Q&A box, and our team will be collecting them for discussion later. Yes, I see that there's someone chatting right here. And this webinar will bring together the Vietnam Asian Hydrogen Club, the Taiwan Hydrogen and Fuel Cell Partnership, the Vietnam Proud Construction Networking, together with our partners, U Hydrogen, S&D Consulting, KPT Chemical, and Indefol. To open our program today, it is my pleasure to invite Mr. Lê Ngọc Minh, Chairman of the Vietnam Asian Hydrogen Club, to share his opening remarks on the context of this cooperation and the objectivities of today's seminar. Mr. Minh, are you available to speak?
Thank you. Good morning, everyone, and welcome to the Vietnam-Taiwan online seminar on hydrogen cooperation. My name is Minh, Chairman of the Vietnam ASEAN Hydrogen Club, VAHC, and it is my great honor to welcome you, the pioneers in clean energy from Vietnam and Taiwan and other parts of the world. Today, we are not just connecting to Zoom screen, we are connecting vision, capability to co-create sustainable energy future. This seminar is one of the activity for cooperation between Vietnam ASEAN Hydrogen Club and Taiwan Hydrogen and Fuel Cell Partnership. We have MOU last year in May 14. Today we are entering in a new activity by turning commitment on the paper into action on tangible cooperation. Why is this meeting important? Because, Vietnam is the right moment for hydrogen development. Our government already made the decision in April 2 years ago by 2024 approving the national hydrogen strategy, targeting from 100,000 to 500,000 tons of clean hydrogen production per year by end of this decade, 2030. And the government also this year, at the same month of April, already listed hydrogen into the National Strategic Technology list. And we believe that all the strong policy signal to the hydrogen business community. Besides that, the carbon market in Vietnam already open. Vietnam already opened the carbon market, creating clear finance incentive for green hydrogen project. On the other hand, Taiwan is also making impressive strides as we observe, from developing electrolysis technology to integrating hydrogen into industry, and especially the dynamics of private company like U Hydrogen, who will make presentation about their technology in this webinar later. I believe we have a perfect match. Taiwan can bring cutting-edge technology, reasonable cost, commercialization experience. Meanwhile, Vietnam can give enormous renewable energy potential, growing market demand, and strong government support. If you observe, you can see our government really active. They try to make the relaxing policy for business community in Vietnam and from other part of the world coming to Vietnam to do business. Thus, I believe this formula for very successful partnership. Our goal is clear. First, to share overview of each side hydrogen ecosystem. Second, to connect potential business across the value chain. And third, to discuss specific cooperation opportunity in this webinar and later on. I am very confident that with the participation of distinguished representatives from Taiwan Hydrogen Fuel Cell Partnership, Dr. Lai, and from the U Hydrogen leader, Vietnam Brown Construction Network, Mr. Steven, KPT Chemical Group, Mr. John Tay, Indefol, Mr. Manuel, and all of you, we will have a good and productive exchange and identify concrete direction to make Vietnam-Taiwan Hydrogen Cooperation a good model for the region. I wish all of you a successful seminar. Thank you.
Thank you very much, Mr. Min, for that insightful opening. Next, I would like to welcome Mr. Sebastian in July, the CEO of the Taiwan Hydrogen Fuel Cell Partnership, to share a few words on the strategic direction of this hydrogen cooperation. Mr. Lai, are you available?
Okay, thank you, Mr. An. And good morning, everyone. I'm Sebastian from the Taiwan Hydrogen and Fuel Cell Partnership. I have to say it's my great pleasure to participate in this webinar. I believe this event can provide a very great opportunity for stakeholders from both Vietnam and Taiwan to come together, exchange our perspectives, and explore the opportunity for the cooperation in the hydrogen sector. Well, so as everyone may know, that the global energy transition is creating very new opportunities for international collaboration. For Taiwan, hydrogen and ammonia have become a very important component for our long-term net zero strategy. I'll giving a very maybe short 10 minutes introduction later. And Taiwan, we are gradually building our own hydrogen ecosystem covering the policy development, the hydrogen production, and also fuel cell and key components, and also the storage and transportation of hydrogen, as well as the application in industry, power generation, and transportation. In the meanwhile, that Taiwan's industry strength is advanced in manufacturing and electronics and energy technology, and supply chain integration can provide very solid foundation for the future development of hydrogen technologies. Well, on the other hand, Vietnam is also entering a very important stage in its hydrogen development. As Mr. Min has mentioned, that's the policy issued in 2 years ago. The countries have provided a very clear long-term direction for building a sustainable hydrogen economy, combined with Vietnam's strong economic growth, expanding renewables, and increasing international investments. We believe that there is a significant potential for cooperation between two of our countries. And the Taiwan Hydrogen and Fuel Cell Partnership, we have been working to connect Taiwan's hydrogen industries, research institutes, and also international partners through our network. We hope to facilitate communication and create opportunities for Taiwanese and Vietnamese stakeholders to better understand each other's capability and needs. We sincerely hope that today's webinar can enhance our mutual understanding and serve as a starting point for more practical collaboration in the future projects in between our countries. And finally, thank you all once again for joining us today. I hope we can have a very productive and insightful discussion and together explore the opportunity for our Vietnam and Taiwan's hydrogen cooperation. Thank you.
Thank you, Mr. Lai. And now let's welcome Mr. Stephen Lu, Chairman of the Vietnam Taiwan Construction Networking, who will share a few words on the role of business connectivity in this partnership. Mr. Lu, can you hear me?
Yes. Yes. Hello, everyone. My name is Steven. I'm the founder of the Vietnam Construction Networking and also SMV Consulting. So I would like to simply introduce about VPC networking. So we operate as a professional construction related community. Also, it's like a chamber or association in Vietnam. So our goal is very practical. So we hope we can benefit all the business people in the construction field, also in the software IT system, because most of our members are related to construction. So from the material supplier, software IT supplier to engineering, designer, architect, main contractor, also industrial investor, developers. So this is why I think a great opportunity to connect the Hydrogen Association from Vietnam and Taiwan, because Vietnam is a growing population market, and also is also a growing market, and the consumer ability is growing, and also due to the ESG topic is getting more mature in Vietnam for those factories who are doing exporting to overseas. So I think it's a great opportunity for us as many potential, I think, consumer or customer in our association for Vietnamese and also for Taiwanese experts who want to explore the market in Vietnam. And also due to that, actually the Vietnamese population, the workers, second generation, third generation in Taiwan is actually the #1 aspect in Taiwan. So why not take the chance to leverage the talent, the second and third generation Vietnamese in Taiwan, and they will be able to cooperate more closely, I mean, in business or in the hydrogen technology to support the Vietnamese technology to grow and also to penetrate this big market together. And maybe in the next step can go overseas to other countries. So our goal is very simple. We try to connect best of the professional people in the field, so between Taiwan and Vietnam. And also we try to connect the potential business opportunity for both sides. So we hope be able to cooperate more further in the future. Thank you.
Thank you so much, Mr. Luke, for those thoughtful remarks. And that will bring us to the end of our opening session. And before we begin, I would like to invite everyone to turn on their cameras so we can take a group screenshot, please. Thank you, everyone. And for our first presentation, I am pleased to invite back Mr. Sebastian from Taiwan Hydrogen and Fuel Cell Partnership, who will give us an overview of Taiwan's hydrogen ecosystem, covering policies, technologies, key projects, and the direction for international cooperation. Mr. Lai, can you hear me?
Yeah. Okay.
Yes.
Okay. Thank you, Mr. Han, and thank you for introduction. Sorry, can everyone hear me and see the slide clearly?
Yes, can hear
Okay.
and also see
Yes,
the
very.
slide.
Okay, thank you. And I think I'll get started. And since I got only 10 minutes and I got very abundant introduction, so I might skip some of the content, but I have forwarded the slides to the host today, so you can also read more details to learn more, and feel free to contact us if you're interested in cooperation with Taiwan. Okay, let's get started. So, good morning, everyone. First of all, I'll give a brief introduction of the Taiwan Institute of Economic Research and also the Taiwan Hydrogen and Fuel Cell Partnership. So basically, the Taiwan Institute of Economic Research, we are a private think tank, started about 50 years ago, the earliest private think tank in Taiwan. So we have been playing a key role between industrial sector and the governmental sector. So sometimes when the government, they want to design some economy policy or resource to advance the industry promotion, they would ask for our opinion. And that's the reason why we have built over 20 different industrial association or alliance in various fields, just in case that some new topics will be on the agenda of the government. For example, and the Hydrogen and Fuel Cell Partnership were one of them, and also included carbon capture and high power device application, and for example, like the UAV and electric vehicle, etc. I'll skip this part. Okay, so let's talk a bit more about the net zero policy and the hydrogen policy in Taiwan. So everything can trace back to 2022. That's the National Development Council. They have designed a net zero carbon emission roadmap by 2050. And based on this roadmap, we have designed the 12 key strategy. And back then in 2022, the hydrogen is listed as one of them. And since we have a shift of president's candidacy, so our nowadays President Lai, he has promoted the 20 carbon reduction flagship projects. And among them, 8 projects goes to energy sector. And again, hydrogen and ammonia, also CCS, is included. And this is the big map of Taiwan's hydrogen policies. So as I mentioned, earliest to trace back to 2022, there are 12 key strategies promoted by the National Development Council. So back then, they want to boost up the hydrogen energy supply from 91 megawatts in 2025 up to 891 megawatts until 2030. But this only refers to the high blend gas to be used in the fire power plant. So we're still working on it. And our now new our new policy for hydrogen is called the National Flagship Project. It's called the Hydrogen Include Ammonia Supply Chain. I'll giving a more detailed introduction later. And for this part, it includes the usage using hydrogen or ammonia as an alternative fuel to support the industrial sector and the power sector to lower their carbon emission. Also, the government has designed a large amount of funding to support the implementation of stationary fuel cell to use it for either high power, large scale power consumer like the AI data center or semiconductor producers. So this is the policy part. If we take a look at the regulation parts, the Energy Administration Act, we have included hydrogen as one of our energy resource, and our regulation for the hydrogen refueling station, and also the subsidy project for the HRS has both been issued in 2023. And our first HRS has been built in Kaohsiung, the west southern part of Taiwan, and it will start operate. We're expecting it to start operating by the end of this year, in cooperation with another subsidy project provided by the MOTC, the Ministry of Transportation and Communication. So the subsidy project provides up to 18 to 20 million NT dollar for each FCEV buses, and they hope to boost up the total capacity up to 60 FCEV buses into service by 2035. And we believe that the first FCEV buses will be start to do their service in later this year. So we're very looking forward for the application for hydrogen in the transportation sector. And not just that, by the last year, August, our National Fire Agency, we have also included on-site power, small-scale on-site production of hydrogen, and also the implementation of stationary fuel cell to include it in the safety guidance to build a more structural and complete regulation environment for the development of hydrogen and fuel cell. Okay, so the next part will be the hydrogen and ammonia ecosystem in Taiwan. Okay, start with the production. Youth hydrogen, of course, I believe that Dr. Zhang, he will be giving a more thorough introduction of their experience and their demonstration site in Nantou. They have combined the PAM electrolyzer with solar PV to generate, to electrolyte to generate the green hydrogen, and the oxygen will be used, pumped into the fishing farm in the Nantou. So it's a very identical case in Taiwan. Another case is called the Pilot Energy. They have a different focus on different type of technology, like hydrogen, they're using the PAM electrolyzer, and the Pilot Energy, they're building their own alkaline water electrolyzer, and with also higher with a very high purity and considerable scale if we deem it as a demonstration site. So not just the production of hydrogen, we are very the small and medium enterprises in Taiwan, we're also very good at innovating our technology. For example, there are four key components. Four companies, they have become the key component supplier to the Bloom Energy in the U.S., including like Cowrie, they provide the hot box, and Porite, they provide the solid oxide fuel cell interconnect plates, and Akbel, they provide the electrical management system, and Plus Metal Tech, they provide their interconnect coating. And we're not just the key component supplier, we can also be a supplier of electrolyzer and solid oxide fuel cell ourselves. For example, like Delta, it's a very known public listed company. They're very world known for their energy saving, energy management in the power electronics. So about 2 years ago, Delta have signed the contract with the British Cirrus Power to acquire their technology for producing solid oxide fuel cell and solid oxide electrolyzer. And their first megawatt scale electrolyzer and the fuel cell lab has been built in Taiwan, and their commercial scale production line for fuel cell and electrolyzer are expected to come up online by 2029. Well, I think I just introduced a lot about solid oxide fuel cell, since it seems to be in short term, is a viable on-site power solution in short term. But in the past, under the support of Ministry of Economic Affairs or the National Communication Council, we have in Taiwan we have developed different type of FCEVs, if in the vast definition, including like go-karts, drones, and boats, forklift, park car, scooter, buses. We're still developing, and our first made in Taiwan FCEV buses are expected to come into commercial scale production next year. And also we have started our first refilling station jointly by the CPC and the Linde in Kaohsiung, and it started just end of the last year. And this is a very complete supply chain you can see in Taiwan's hydrogen industry. So for the left-hand parts, you can see from the raw material marked in green, and the stack marked in blue, and the system application marked in yellow. These are the key players, key stakeholders in the fuel cell business. For the right-hand side, we define it as peripheral product, but mainly we refer to anything that you can think about when we're talking about the hydrogen ecosystem, including like the storage tank, the methanol production and supply, and the ammonia storage and transportation and production, and also, of course, hydrogen production, and some standards and the industrial service. So you can see that it's a very complete supply chain, or very complete ecosystem in Taiwan. And if you're interested, feel free to visit the official website of the Taiwan Hydrogen and Fuel Cell Partnership. You can also scan this QR code on this slide. It can lead you directly to this industrial chains map. Okay, sorry. I think I got only 10 minutes, so I try to make it short. Thank you.
Thank you, Mr. Lai, for that comprehensive overview. It really sets the stage for understanding where opportunities lie. Next, I would like to invite Chairman of Hydrogen Technology, together with Dr. Chen, to introduce their PEM and AEM technologies, product line, supply capacity, and the opportunities for distribution and manufacturing cooperation here in Vietnam. Dr. Chen, can you hear me?
Yes, I can hear you.
Oh, good. Okay.
Okay. Hold on a second. Let me share my screen very quickly. Okay. So can everyone see my sound, see my screen, and hear my voice?
Yes, thank you.
Okay. So good morning, everyone. This is Brian Chang. We This is from New Hydrogen. It's my great pleasure to have this opportunity to share our progress in hydrogen technology, as well as the role that we believe the new hydrogen can play in the future for the hydrogen economy. So let's begin the presentation. Okay. So first, this is our company's milestone. U Hydrogen was founded in 2017. From the beginning, we focused on hydrogen production through the PN technology, like a PN water electrolysis. And in 2018, we developed our titanium electrolyzer stack. In 2019, we launched the related application products. And also in 2021, we expand upstream into the catalyst coating technology. And today, U Hydrogen is among Taiwan's most integrated hydrogen technology company. In 2023, we invest heavily in industrial and energy applications. And in 2024, we received a Business Startup Award from the Taiwan's Ministry of Economic Affairs. Okay, so let me briefly explain the PN technology. PN electrolysis is closely related to fuel cell technology, but the process works in the opposite direction. In a fuel cell, hydrogen reacts as a oxygen. It reacts with the oxygen from the air to generate electricity. And if the pure water is pure produced like the byproduct. However, in the PM electrolysis, we apply direct current to purified water and separated it into hydrogen and oxygen. The underlying chemical principle is the same, but the direction for the reaction is opposite. So the PN technology can produce very high pure hydrogen because it operates as a hydrogen, spread hydrogen from water directly. The system can be more compact than conventional alkaline electrolyzer, while it can deliver the higher current density. So we can make things more compact and with a higher operation efficiency. So let's take a look the pain point of the hydrogen supply chain. Here you can see this the hydrogen is produced from the centralized production line. So many factories, they use hydrogen as a raw material and or the protected gases, while supplied from the centralized industrial gas producer. So the gas is then compressed for transportation. This might add a lot of costs and also a lot of carbon emissions. And then it's reduced pressure again in customer side. So the supply chain creates, a lot of extra costs, and also the operational is very inefficient. So here is our solution: on-site hydrogen generation. Our solution is, on-site hydrogen generator producing hydrogen exactly where it needs. So instead of rely on long supply chains, we can produce a custom line. We can provide customer with a higher purity hydrogen directly for their needs, because the PM water electrolysis they can produce a very high pure hydrogen at the appropriate pressure. So it reduces the needs for long-term transportation, and it can provide enough the pressure like the 10 bar to avoid the further safety concern and regulation cost. And so as a result, the customer can lower their operation costs and also their the carbon emissions. So why the on-site generation is the future? That's because the first is it can significantly reduce the overall cost of a hydrogen supply by removing the unnecessary transportation, compression, or the handling. Moreover, it can improve the safety because the customer do not need to store the hydrogen in a larger amount. So it can, this is a flammable hydrogen on site. So it can also reduce the safety risk at very high pressure. And the third, On-site generation gives the users great control over their hydrogen supply. So it can improve the stability, reliability, and also it can, I think this is the most important, it can support the ESG goals by reducing the carbon emissions and enhance the more the sustainability of an energy solution. So in addition to our hydrogen generation system, we also develop a larger range of testing platform in-house. Since there are no local supplier who are able to provide this kind of equipment, so we have to build everything from the ground. And now we are able to provide several different partners with our test platform. We currently support 4 or 5 like the university, research institute, or organizations in Taiwan who are highly doing the hydrogen-related testing system right now. So besides the hardware, we also develop an in-house software system, which with this tool we can monitor our product and test platforms in real time. So if any issues occurred, we can our system can provide earlier warning and allow the remote intervention. While it can help us to prevent the equipment problems and reduce the operation and maintenance costs. So here's our Nantou hydrogen demonstration project, and this page just showed you that this is the concept of how we integrate green energy with hydrogen production. This system integrate with 80 kilowatt solar array that provide power to our electrolyzer. So this is presented as Taiwan's largest scale hydrogen production system that can produce up to 100 liters per minute. Okay, so let's take a close look of the system. You can see our hydrogen production system. This one is 100 liter standard liter per minute. The system have a power range approximately like 30 kilowatt. It can make up it's consisted of 4 electrolyzer stakes. Each stakes produce 25 liters per minute of hydrogen. And so altogether, the system delivered a total production of 100 liters per minute, which is equivalent approximately 6 cubic meter per hour. So here is our system architectures. This is just showed you the overall architecture of our system. The 80 kilowatt solar array, it can divide it into 2 sectors. The 40 kilowatts are allocated to the water electrolyzers and for hydrogen production system. And in addition to the solar power, the system can also use the green electricity. So this ensures the hydrogen production can continue when solar generation is insufficient. The hydrogen and oxygen are produced by the system and then it compressed and stored in a hydrogen and oxygen cylinder. So the system can also integrate with the downstream fuel cell for other applications. So here's our core technology. The first and most important is our PM hydrogen module. This this modules is the first and most our the long-term develop the technology. It can operate at a high current density, about 2 amp per the square centimeter, and which give us a relatively strong operation efficiency. And the current is and yeah, this is, I think, is the current density is highest among our competitors. Also, this system currently is the largest domestic manufactured core hydrogen production system in Taiwan. Okay, let's see it. The other core technology we have developed during the project is metal hydride thermal compression. And traditionally, hydrogen compression require expensive mechanical compressor. And so this is a very we have a very tight budget, so we need to we try to figure out another alternative way to compress the hydrogen. And with the metal hydride, I think this is the most easy and safe way to compress hydrogen from the very low pressure. Through this, because the metal hydride, it can absorb hydrogen at low temperature, at low pressure, and then release it at higher temperature and higher pressure. So with this mechanism, we can increase the hydrogen pressure in a safer and more innovative way. It reduces the risk associated with the strong or the the safety concern of hydrogen, and we can store it and handle the hydrogen pressure very easier. Okay, now this slide shows the we have a small size other than 100 liter per minute system. This is a 50 liter per minute hydrogen system, and this system is designed for applications in the industrial application. And it consists of two 25 liter per minute electrolyzer modules, and also the power consumption is about 15 kilowatt. And we already successfully export this system to United Kingdom, and because the customer is satisfied with its performance, so they place another order for the system, and we are currently working the production for that. Okay, and here are some the compact hydrogen generator from the 1 to 10 liter per minute. These systems are supplied for a wide range of custom applications because they're compact size and they can be integrated more easily into different type of equipment or the operation environments. We can also customize this system according to customers' requirement, and so according to their hydrogen purity, dew point, or other performance applications. Okay, now here's our health and wellness product. This page just introduce the hydrogen related product from for the health and wellness applications. In additional to industrial and energy sectors, molecular hydrogen has attracted a significant research interest in the health and wellness field. More than 2,000 academic publications have been explored in this field, and they found the hydrogen, molecular hydrogen, has a huge potential in this application. Since the U Hydrogen Fund in 2017, this is one of a major product category that contribute to our revenue. The product shows we have a hydrogen inhalation system and hydrogen water machine, and also some very compact hydrogen generation stake for this kind of applications. Okay, here we show our intelligent application properties. U hydrogen currently hold more than 10 related patents. This patent reflect the technology capability and experience we have accumulated over the past 10 years. And we also provide a very important foundation for our ongoing product developments and future expansion. Okay, now here shows the other R&D development trends. AMD, which is very important for our next generation hydrogen production technology. U hydrogen already is have a very plenty experience and technology in PM. And based on this foundation, we have now invested a lot in AEM, an ion exchange membranes. So this kind of electrolyzer is a little different from the PM because it offers some different advantages. However, it's still less than the mature. So worldwide, a lot of research institutes, they have invested a lot also on this technology. So the next page, we will show you why this is very important for hydrogen production. So let's take a look at the advantage of AEM compared to PM. The one of the biggest advantage is in the AM because it has a potential to reduce the or to avoid to use the precious metal because in PM we use a lot of the catalysts. These catalysts are made by the precious metal. So in this way, we can significantly lower the catalyst cost. And one important thing is that in a PM, they have anode and they use a lot of because the anode it requires a lot of material treatment to satisfy the PM environments, and it's actually is very costly. So compared to the PM operation environment, AM can significantly reduce the material treatment and as well as reduce the catalyst. So AM right now, many research institute, they are interested in this field. Okay, so let's compare to our best our performance with the best in class of AEM manufacturers. Right now, there's only one global benchmark, which is an actor who are in this field dominate almost all the commercial AEM system. So our AEM stake we can currently produce is about 15 liter per state. So which is a little larger than our benchmark adapter. And the internal benchmark, the current density is approximately twice of that the adapter, which is 1.5 m square centimeter. And also the efficiency is a little higher than our benchmark. Okay, so here shows you the AM reliability and stability. Uh, for a this is the most challenging of AM development because the AM all uh, currently is suffering from the long-term ability because of degradation issue. But in our preliminary 1,000 lifetime test, we operate at the voltage remain, almost below the 1.8 volt, which is very, very stable. And currently we estimate the degradation at about 0.05 volt, millivolt per hour, which is very low. So with this degradation rate, we estimate the lifespan. It can be more than 7,000 hours. And this is still an early stage test. We have not yet used the best operation parameters. So there is still a further room to improve the lifetime performance. And also the chart below, it compare 30 micron and 80 micron membranes. Right now, we are using 18 micron membranes for a long time lifetime test. And if we use the 30 micron membranes, and it can reach the 1.82 amp per square centimeter. So which indicate the further performance can be improved. Okay, here's the I would like to show you the another new development directions. Electrochemical hydrogen compression and purification. This technology uses a PE membrane to move hydrogen from the anode to cathode. Because the membrane is selective, it can separate hydrogen from other gases, so it can achieve the hydrogen purification. At the same time, by applying the voltage, the system can also increase the hydrogen pressure. In this way, chemical hydrogen compression can achieve both hydrogen purification and compression in a single process. So this summaries the core technology platform like PM, AEM, and also the EHC hydrogen compression. By integrating this technology, we can serve as a wide range of applications, including like semiconductor, healthcare and wellness, high purity hydrogen for laboratory or low carbon hydrogen for industrial use, and also the energy storage applications. In the future, our chemical hydrogen compression system may also enable hydrogen recovery and reuse. So this can improve our overall energy efficiency and further hydrogen reduce carbon emission. So this slide just to present our long-term visions. We aim to evolve from a technology developer, the equipment supplier into a hydrogen as a service or a HAS, the system integrator. Rather, than simple equipment provider, we want to provide the customer with the hydrogen as the we want to provide customer with the hydrogen they need as a service. So this approach can lower the cost adapting the new technology that allowing us to integrate the different technology and develop the most efficient way overall for a better solution. Through this model, we can create a long-term value for our customer while generating the revenue from the service. Okay, so here is our conclusions. We thank you so much for to hear my presentation and for your attention. And if you have any interest or the need to related to the hydrogen production, hydrogen utilization, or the related technology, please feel free to contact me directly. And this is the QR code you can scan that can directly link to our FB page. And so here I'm very pleased to we can arrange the future discussion with you. Thank you.
Thank you, Dr. Chang, for the excellent introduction to you hydrogen technology and capabilities. And so now we're going to move next to the next discussion session. We will be open to floor the question. And we already received some great questions in the chat, and we welcome more. Please continue sending them. And for this discussion session, I'd like to invite our panelists to turn on the cameras and join me, Mr. Lê Ngọc Ánh Minh, then Dr. Cao Thúy Anh from VAHC, Mr. Sebastian Lai from THFCP, the chairman and Dr. Chang from U Hydrogen, Mr. Stephen Lu from BBC, Mr. John Tay from KPT Chemical, and Mr. Manuel Baumgartner from Indefol. Please welcome everyone.
Yes,
Thank you. Thank you. Very happy, and we learned a lot from your presentation, from Dr. Lai of THFCP and Dr. Chang from U Hydrogen. We have in this webinar also the representative from Indefol. Indefol is a hydrogen pioneer in Vietnam. They already have the pilot project. And also we welcome the representative from KPT Chemical. They are from Malaysia, but they have been doing business in Vietnam for a long time, for more than 15 years. So I would like to invite Mr. Manuel from Indefol. Please introduce about your business, hydrogen business in Vietnam, and what you need from our partner.
Okay. So first of all, hello everyone, and thanks for welcoming me to this webinar. And so you asked the right question, because you asked me what I need, yeah? So I need a 21 megawatt proposal AEM. So can be an estimation, because we are working on a 40 megawatt fuel cell project in Vinh Long, and we want to do like it's 42 megawatt, yeah. And we want to work on 21 megawatt ourselves with alkaline electrolyzers, but AEM seems to be the future, yeah. Looks like it. So hydrogen is the future, and on top of hydrogen is AEM the future again. So we would be intrigued about a 20 megawatt proposal from U Hydrogen. Okay, so I start with that because you asked me what I want. Okay, so, but okay, now I know this is a very abrupt start, so to speak. Okay, but okay, just a short introduction of myself and Indefol. So my name is Manuel Baumgartner. Everyone in Vietnam or also in China calls me Sunny because it's easier. Okay, and so obviously I'm the hydrogen director for Indefol. Indefol is a Vietnamese company with German investors, founded in 2008 into wind and solar rooftop projects until 2022. And then in 2022, we decided to focus mainly on hydrogen only. And so we got 100 megawatt of rooftops deployed, mainly for suppliers, for Adidas, Nike, Puma, New Balance, etc. So in the garment shoe sector. And Nike pushes us now to decarbonize them and to make them energy independent. And we started with a smaller project up there in Ninh Binh, with the Victory factory, that's a supplier for Adidas. And now, almost now in a month, less than a month, on the 21st of September, we have an inauguration for a 42 megawatt fuel cell project in Vinh Long for Lai factory. And as it happens, that's a Taiwanese factory. So that's why it might be a very good fit, actually, because most of our customers are Taiwanese. So they are, as I said, Lai, or obviously Formosa. We also work with Formosa a lot. And Lai, they are the first one with the 42 megawatt. And once they are deployed, we try to convince everyone to work with hydrogen storages for the baseload. But not only for that, we also want to implement there in Vinh Long 17 megawatt of wind energy. And so it will be a combination of solar and wind to power that hydrogen. And then we also need the fuel cells. We need the fuel cells because we also work on mobility. We also work on hydrogen trucks and hydrogen coaches and hydrogen trains and hydrogen cars. And now it sounds like a lot we are into. Yeah, it's very dynamic. So, and in Vietnam, we have we have one operational factory in the former Long An province, which happens to be the Tay Ninh province now, and we're working on another one. Actually, tomorrow the Deputy Prime Minister is supposed to happen to sign that off with us in Cantor. We happen so there should be like a 1 gigawatt hydrogen hub coming, and we'll be working on a third one, probably in Yalai in the highlands, powered by wind. And on top of that, we already purchased land in France around Poitiers for another hydrogen hub project to become supplier for Airbus. And because Airbus is based in France and in Germany, and the other Airbus hub, if everything goes well, should be in the north of Germany around Hamburg, because there's the other Airbus factory, so to speak. So, but that was a lot what I'm talking about. But for the moment, coming back to the moment. For the moment, we are focusing on this 42 megawatt Vinh Long factory the most. And this is where we need some help, because 42 is a bit too much for us. And this is why we would be happy to receive an AAM proposal for 21 megawatts. Okay, do you have any questions? Sorry, I didn't prepare a presentation because I'm also working from my private laptop and I have no presentations here.
Thank you, Mr. Sony.
Welcome.
I think this is the real. So from VAHC member and partner, we bring the real project, and these gentlemen, they are ready to work with you through Taiwan Hydrogen and Fuel Cell Partnership and you Hydrogen and your partner. And I would like to invite the next panelist, Mr. John Tay from KPT Chemical. Please share your business introduction and what you need from Taiwan. Thank you.
Okay, thank you, Mr. Ming, for inviting me for this session as a panelist. I'm John Tay, CEO of the KPT Group and Director of the KPT Chem. So basically, a brief introduction on our company is we are actually this chemical and energy company in Vietnam, and we have been starting from 2009 in Vietnam, and currently our chemical business and our energy business is mainly focusing on the clean energy. So for our chemical business, we are actually the specialist in ammonia, and back to the hometown. I'm actually from Malaysia, so we are actually back a lot from the system of the Petronas. And currently in Vietnam, we have our own storage and terminal in Domain Province. And also the whole technical team and transportation system for the all kind of gases beside ammonia. So hydrogen, we also actually transporting hydrogen. And back into the hydrogens, currently in the January of 2026, we actually have a roadshow in Vietnam for the solid state hydrogen transportation technology, together with the Hydroasia from Shanghai and the SEDC from Sarawak, Malaysia. So back to this, we are actually providing the whole infrastructure, terminal, storage, and the logistics system for the these hydrogen gases. We are also looking for the partnership in the technology of further end, like these fuel cell vehicles refueling system, and combining with our solid state this hydrogen storage, so that we actually looking at to pushing the whole hydrogen economy further into the real application, looking further on the more efficient in the cost, and at the same time, we are also looking at this the off-grid small size off-grid hydrogen green hydrogen productions that combine with our this solid state storage and also some of the solar and the wind system to actually provide this energy at the islands of the urban areas. We are not only focusing in Vietnam, actually, we have offices across the Southeast Asia, in Singapore, Malaysia, Indonesia, Thailand, and Philippines. So yeah, so I think the technologies like for the new hydrogens is very, I mean, we are very excited to see this technology, that there are a lot of applications that the small size and off-grid these hydrogen productions that can actually combining with our fuel cells or the technology of the hydrogen fueling stations to actually pushing the hydrogen economy further and widen the applications worldwide. Thank you.
Thank you so much. So because our time is limited and we can discuss more and more, we also received few questions from audience asking you hydrogen, some specific technical question. And also we have a question from Dr. Sandeep from India. He raised concern about standard. So whether in Taiwan you have the common standard for each sector or not. So I believe that because our time is limited and we can reply to you via email or through the next meeting. And I would like to invite Dr. Lai to give some input after our webinar.
Okay, thank you, Mr. Min. And I think for so many audience today, I think we got 40 of us joining us today, and although our speaker, 1 hour is very limited, and I believe that we can have some very great future cooperation spaces. And I would like to also share something to John. You just mentioned that your company that have several space, KPT Chem have several sites among the ASEAN country. And one case that we have in Taiwan is that it's called one of the chemical company. They're also importing and producing their own ammonia for Taiwan's markets, agricultural markets. But they start to realize that there are some potential for using ammonia as a fuel to put into the fuel cell to generate electricity. So they start to building their first, small scale. I think it's about 400 to 500 kilowatts fuel cell that you can. It's a one-stop solution. You put in the ammonia to generate and crack it into hydrogen and to put it into the PAM fuel cell to generate electricity. So I think that could also be a direction that our Taiwanese company can work with the KPT Chem. And I believe that's just one of the cases that very limited time. I believe many of our audience, you all have your own business that you're specialized in. And I have to say that the limitation is our imagination would be the only limitation for the usage of hydrogens in various fields, not just electricity, not just power. So looking forward for more dialogues in the future. And I believe that after today's conference, you can all have our contact and feel free to visit our website to find out more. Thank you.
Thank you very much.
Thank you for that. And we, because of the time, so now we're gonna move next to the final. That will be the closing remark. And I would like to invite Dr. Cao Thuy from VAHC and Mr. Stephen Lu from VPC to share a brief summary of the key points from today and the next step for this cooperation. Please, Mr. An.
Hello, everyone. I'm Cao Thuy from Vietnam Asian Hydrogen Club. And as we conclude today's Vietnam Taiwan Hydrogen Cooperation online seminar, I would like to sincerely thank all our speakers, panelists, partners, and participants. And my special appreciation goes to Mr. Lê Ngọc Ánh Minh, Chairman of Vietnam Asian Hydrogen Club, Mr. Sebastian Yen Chun Lai, Deputy CEO of THFCP, Mr. Stephen Lu, Chairman from VPC, and especially Dr. Chang from EU Hydrogen Technologies. And many of you are not only our distinguished experts and partners, but also familiar friends whom we regularly meet through our monthly seminars, conferences, and workshops. And we also have here Dr. Sandeep Durat from Mumbai, India. You joined our seminar on last May, right? And Dr. Masahiro Kawamura from Japan, Dr. Sonny from Indefol, and Mr. John Tay from KPT Chemical Group, Malaysia, and also other distinguished guests. And your continued contribution of knowledge, experience, networks, and new ideas is helping Vietnam Asian Hydrogen Club build an increasingly connected international hydrogen community. And today's two presentations gave us two complementary perspectives. The first show how Taiwan is moving from hydrogen technology development toward an inter-ecosystem linking policy, technology, enterprises, supply chains, and end-use application. And the second introduced EU hydrogen's pathway from PEM based on-site hydrogen generation toward AEM, electrochemical hydrogen compression, high purity hydrogen, and ultimately hydrogen as a service. And the key message is very clear here. Hydrogen cooperation should move beyond information, strength toward practical connections among technology projects and supply chains, markets, and investment. And we hope today's webinar will lead to concrete next steps, particularly technology cooperation, equipment, distribution, and manufacturing, and demonstration projects, also stronger Vietnam-Taiwan industrial linkage. And thank you again for being part of this journey. We look forward to meeting all of you at Vietnam Asian Hydrogen Club upcoming seminars, workshops, and conferences. Thank you.
And Mr. Stephen Lu, you.
Yes, okay. So first of all, I would like to thank all the participants, and also all the speakers, and also all the organizations from the Taiwan Hydrogen Cell Association, and also Vietnam Asian Hydrogen Club, and also our construction networking club. So summarize in short. So I hope the hydrogen technology can be able to apply to in more consumer and also daily life and also industrial parts. So that is the value can be applied. So that is why for VPC networking, so we commit to connect all the professional peoples in Vietnam and also in Taiwan, and not just Vietnam and Taiwan. So we are also cooperating with all the foreign exchanges and also local Vietnamese chambers to help and to export their capacity, their tenants, and also expand the market to support mutually. So we are hopefully will be able to do a new coming seminar with more experts in the field. So that is my comment. Thank you, and thank you everyone.
Thank you both for the excellent
Thank you very
summary.
much, and see you again.
And of course, thank you all of you, our attendees, for joining us today and for excellent question. And this will be concludes our Vietnam Taiwan Hydrogen Cooperation webinar. Thank you all and have a great rest of your day, evening. Thank you.
Thank you.
If you want to have
Have a good
more
day.
different seminar, please email us so we can design the seminar in the future to support our hydrogen experts globally. Thank you. Have a great day.
Thank you.
Thank you.
Cảm ơn. Bye bye. 大家台湾见，台湾的朋友。See you, see you.
Okay, bye-bye.
Bye. See you.
Thank you, Mr. Minh. Bye-bye.
Thank you. See you.